Okay, and in this video, we're going to talk about the process to determine the inverse of a function or the inverse function. So in the last couple of videos, we discussed the relationship between functions and their inverses. We discussed sometimes how the functions can have restricted domains such that their inverse is a function. And in this video, we're going to talk about how to determine the inverse function. So the best way that I like to do these is I like to go through some simple examples and write out the steps with you as we work through our examples. So I'm going to leave myself some steps here. So I'm going to have step 1, step 2, and step 3. And we're going to go ahead and look at this example. So most of the times they would say determine, the instructions would say determine the inverse of f of x, and it could be f of x, g of x, h of x, and we'll say given f of x is equal to a value of 3x plus 2. So this was the same function we discussed in the last video if you're watching them in continuity. But here, regardless if you know what the inverse is already, we can work through it step by step. So the first thing that I like to do is that I like to replace, that's supposed to be a C, replace, there we go, replace f of x with a value of y. So we're going to replace f of x with the value of y. So I'm going to say this right here is our step 1. So I'm going to identify step 1 right here, and we're going to let f of x be equal to y, and we're going to say y is equal to 3x plus 2. In our next step, everywhere we see an x, replace with y, and y replace with x. So everywhere we see x, replace with y, and every time we see a y, replace it with x. So let's go ahead and identify here in step 2. So we're going to replace y with x. So notice here we have a y. We're going to replace y with x. And here we have an x, and we're going to replace x with a value of y. So 3y plus 2. OK, so that is just how simple step 2 is. Everywhere you see an x, replace with a y. Every time you see a y, replace it with x. Now in step 3, we are going to go ahead and solve for y. So now we're going to go ahead and solve our equation for y. So let's go ahead and identify this as step 3. So now, if we have x is equal to 3y plus 2, first thing we're going to do is we're going to subtract 2 on both sides. So we're going to get x minus 2 is equal to a value of 3y. In order for us to get y by itself, we're going to have to divide both sides by a value of 3. So over here, my 3's would cancel. And we're going to have x minus 2 all over 3 is equal to a value of y. And this is the same thing as me saying y equals x all over 3 minus 2/3. So remember, we can split up those numerators as long as we have one common denominator. So we can split them up as such. And we can make it more of a form of y equals mx plus b, where we have a slope of 1/3 and a y-intercept of negative 2/3. So this right here is our final solution solved in terms of y. And in our last step, I should have actually written 4 steps on here. In our last step, the last thing we're going to do is that we're going to place y with f inverse of x, or you're going to replace it with g inverse of x, or replace it with h inverse of x. Whatever your function was called, you're going to replace it with the inverse of that function. So we're going to come down here in step 4, and we're going to come down here in step 4, and we're going to rewrite this as f to the negative 1 of x, which stands for f inverse of x, and that's going to equal to 1/3 x minus 2/3. So actually, I just pulled out this constant of 1/3. And I left it in the form of y equals mx plus b. And we can write this as x minus 2. And this is the same thing as saying x minus 2 over 3. And this is the same thing as saying x all over 3 minus 2/3. So there are multiple forms that this can take. So if you are working through some textbook questions, or if you're working through some other questions you found somewhere, you may arrive at a different form of the solution than a colleague, and you just have to realize that they are just different forms of the same things as long as you went through the process correctly. So there are many different ways of writing these out, and that's dependent upon usually the way that you feel most comfortable presenting your solution. So this is a great example of f inverse of x, determining f inverse of x from our given function. And just make a little star, make a little remember to yourself. How can you check your work? I always like to remind people how they can check their work. And we can do that using the composition of two functions. So remember that f composed of f inverse of x is equal to x, and that f inverse of f has to equal to x as well. So if you want to test your two functions and see if they are inverse and you did all the process and you did the processes correctly, you can use this. And if you go back to my last video, the one that I entitled Inverse and Inverse Functions Part 2, I actually did this example in Part 2. So we actually went through and did that little form of a check in Part 2. So now if I were to go ahead and look at these, functions, I'm going to draw them on a graph. So I'm going to go ahead and let f of x equal to 3x minus 2, and I believe that was my initial function, 3x plus 2. And then I'm going to say in a different color, let's go ahead and use pink, g of x, f inverse of x, not g of x, f inverse of x. And that's going to be equal to, I'm just going to write it as 1/3 x minus 2/3. I like writing the form of mx plus b so I can rapidly identify my slope and my y-intercept. So now I'm going to go ahead and graph these the best that I can on a line. So I'm going to give myself, on a graph. I'm going to try my best to graph these graphically and actually show proper dimensions. So with my first example, y equals 3x plus 2, I recognize it has a slope equal to a value of 3. And it has a y-intercept of a value of 2. So I go up here and I have the value of 2. I know I'm going to have this point right here. So I know that my slope by definition is rise over run. So slope is equal to rise over run. So I am rising 3, running 1. So I can go up 1, 2, 3. I can go over 1. So this will be my next point. I can go up another 3. And run another point. And I can also go back 3. Remember, this is -3 over -1. I can go back 3 and go, down 3, not back 3, down 3. So there we go, 1, 2, 3, and then over 1. There we go. So trying my best to line these up by drawing them without graph paper, I'm going to have something that looks like this. Hopefully that's the best that I can draw, so I should try a little bit better. Let me just try this a little bit better here. Make them intersect these same points. 1, 2, 3 to over 1. So it's going to be something that looks like this. Okay, so it's going to be something that looks like that. So it should be more linear, but this is going to be my function f of x. And now in pink, we're going to go ahead and graph my f inverse of x. So I realize my first point is going to be 0, -2/3. So that's going to be approximately right here. I'm going to go ahead and I'm going to try to plot some points and make this a little bit easier on myself. But again, nothing's really going to be that easy about plotting points. We're working with something that looks like this. But I recognize that I'm going to be going up. I'm going to go up 1. So if this is -2/3, if I go up 1, I'm going to be at -2/3 plus 3/3, which is a value of 1/3. So I'm going to be up here, and I just don't want to run 3 over 3. It's going to look something like this, and then it's going to look something like this. So I'm just going to try to extrapolate these points based off of the trend that I know it will. And if you have more time, go ahead and graph these out to be more specific. I'm just going to try to give you a general gist of what our inverse function line looks like. And it looks something like this. So hopefully we can all see the line that I created. So this right here is going to be f inverse of x. So one thing that you're going to notice, and hopefully you can notice from my drawings, is that if I go ahead and draw in the line y equals to x, so I'm going to do that in, let's do it in a different color. Let's do it in bright green. So if I were to, and I'm going to draw this using a straight line, here we go. If you look at the line y equals to x, hopefully we recognize that there is some symmetry. There is some symmetry that exists between these two functions. So if you were to fold this graph along the line y equals to x in half, if you were to fold it down this line, we would have the mirror image of both of these sides on their own. So you'd have the mirror image of this, and this would fold and flop and give you this on this. So that's one of the interesting characteristics about functions of their inverse, is that they are always graphically symmetric about the line y equals to x. So let's make a note about that. So if that ever comes up on a question, or if you have to graph two functions, this will help you. So a function and its inverse are always, and this is an always statement, symmetric about the line y equals to x. So hopefully you can see some symmetry. And go ahead and take out your graphing calculator to show how this works. You can graph both of them, graph all three of the lines, y equals to x, the function 3x plus 2, and the inverse function 1/3 x minus a value of 2/3. So hopefully you can do that graphically. So let's go ahead and look at another example of a function. Let's say in this example we want to determine, so we're going to say let g of x equal to x squared, and we want to determine the inverse of g of x. So we say, okay, we want to find the inverse of g of x. But hopefully we can remember these steps from before, so you can go back and reflect on your notes if you don't have them ready or handy, or you haven't memorized them, which I understand. So the first thing we're going to do is that we're going to let y equal to g of x, and we're going to keep that as y equals x squared. So this is going to be our step 1. Replace g of x or f of x or whatever the function is called in terms of x, replace with the value of y. And next thing we do is that in step 2, everywhere we see a y, we replace it with x. Everywhere we see an x, we replace with a y. So we have a y here, we're going to replace that with the value of x. And this is now going to be equal to a value of y squared. In step 3, we want to solve for y. So if I solve for y, I'm just going to rewrite this as y squared equals to x. In order for me to solve for y, I'm going to have to take the square root of both sides. So I have to take the square root of the left side of the equation, take the square root of the right side of the equation. But hopefully we recognize that when we solve, we have to add that plus or minus square root of x. So be very cognizant of that. When you solve for the variable that is squared by taking the square root, you always have to get that plus or minus out in front of it. So if we examine this, and this was step 2, and this was step 3, and then last thing in step 4, we are going to replace y with our inverse, the name of the inverse. So that's going to be g inverse of x, and that's going to be plus or minus square root of x. So if I look at this as I've done before, I'm going to go ahead and draw x squared here in red. So it's a parabola opening up, and it looks something, that's a horrible parabola opening up. It's a parabola opening up, and it looks something like this. Okay, and I'm going to go ahead and draw g inverse of x, and we'll label this g of x. And now g inverse of x, here is the positive square root of x, and then here is the negative square root of x. And this right here is g inverse of x. So graphically, if we examine this, and again, I'm going to draw that line y equals to x. Actually, I think I did a pretty decent job. Of, there we go. I did a pretty decent job of hopefully determining and showing you that symmetry that exists. So hopefully we can see that symmetry that's there. And this g inverse of x should curve up a little bit more, so I could write it like that. But for right now, I'm pretty content with that drawing. So I do see symmetry about the line y equals to x. And again, if you have problems seeing that with my slipshod drawing, you can go ahead and draw a graph it on your calculator to check it out. But notice that g inverse of x is not a function. It does not pass the vertical line test. So in this circumstance, we really can't say g inverse of x. We can't really call it g inverse of x, because I would assume that our inverse is a function. So what we often have to do is that we are going to have to restrict our original function. We're going to have to restrict the domain of our original function. So if we restrict the domain of our original function, sorry about that, we could say that g of x is equal to x squared, but I'm going to have to either pick a positive portion of this or a negative portion. But I'm going to say that here we're going to have a domain, and we are going to restrict it such that x is greater than or equal to 0. And notice if I do that, we're going to see that this portion, this negative portion, erases. So we don't have this negative portion anymore because that is not part of our domain. So here's our original portion of g of x. But if I erase my negative portion, then I know g inverse of x will only equal to the positive portion of the square root of x. The positive portion, because that negative portion will go away. And now when I erase the negative portion, the negative square root of x, notice I still have symmetry that exists along the line y equals x, but now my inverse is also a function. So notice here I had to restrict my original function such that its domain was given to us. I restricted our original function such that its domain guaranteed us an inverse that is also a function. So I know that might take a little time to wrap your head around because it is a little bit complicated. So sometimes you might have to say it, you might have to try practicing a couple examples. But try some even functions and see if you can do that. But more specifically, you can worry about some of your trig functions. So as we get to trig functions, we recognize those guys are functions. However, they would never pass a horizontal line test, so they would never be one-to-one, and therefore they definitely need some domain restriction in order for their inverse to also be a function.